All right, let's look at some data analysis. So first, we are going to look at seeing how different values that are added to a data set can affect the mean and the median. So, an outlier, if you don't already know, is a data point that is way out of range in regards to other data points. So something that is way higher than the rest or way lower than the rest. And it's going to have an effect on the data because it doesn't really fit in with the rest of it. So in this example, we have 55, 43, 58, 47, 276, 45, 51, 56, 48. This one is very clearly way higher than the rest. It's not always going to be that much bigger, but that one should be pretty clear that it is. So how do outliers affect the mean and the median? Let's look at this first example. There were 4 dogs at a vet's office. The weight of the first 3 dogs were 52 pounds, 48 pounds, and 50 pounds. The 4th dog weighed 22 pounds. If the dog that weighed 22 pounds left the vet, how would the following measures of center of the data set be affected? So our question is saying, if the dog that weighed 22 pounds left the vet, how is that going to affect the data? So we already did the calculations based on the original data set, which is those 4 dogs. The mean would be 43, the median would be 49. Our new data set, we are losing the 22. So that outlier, because it's way less than the rest, is gone. So now we're just looking at 48, 50, 52. So we got rid of that outlier, the number that was way smaller. And now we're going to recalculate the mean. So we are doing 48 plus 50 plus 52 divided by 3 values gives us a new mean of 50. For the median, now we are just crossing off. Lowest, highest, we are left with 1 value in the middle, and that is 50, so our median is 50. So what happened to the mean? It increased. And what happened to the median? It just barely increased. Okay? So it really didn't affect the median that much, but the mean, it did have a big effect on it because the original one was lower because this value brought it down. That outlier brought it down. All right, example number 2. Baxter Healthcare has 3 accountants with the following salaries: $50,000, $60,000, $55,000. For extra help during tax season, they hired an intern with a salary of $10,000. How would the following measures of center of the data set be affected by the new hire? So our original data set is just the original employees, 1, 2, 3, and then we have that listed here. We've calculated the mean would be 55,000, the median would be 55,000. Our new data set, we have to add in this low intern salary of $10,000. And then the rest are still there, the 50,000, the 55,000, the 60,000. And now we're going to recalculate. So our mean, 10,000 plus 50,000 plus 55,000 plus 60,000. And divide this time by 4 people working is 43,750. The median, we would cross off lowest, highest. Now we have these 2 in the middle, and the average of those 2 is going to be 52,500. So our mean decreased, and our median just slightly decreased. So this value of 10,000 really affects the mean because if we look at it, this is saying that the average salary is 43,000, but 3 of the 4 make more than that. So this extreme outlier brought the average pay down to less than what the majority of people make, which isn't really an accurate depiction. And then last one, Adam and his 3 friends are in a bowling league. His friends' all-time high scores are 180, 224, and 205. Adam's all-time high score was 250. After this week's game, he had a new high score of 290. How would the following measures of center of the data set be affected by Adam's new high score? So let's think about the original. We had 180, 224, 205, and Adam's old score of 250. That's what it was prior to this week, which gives you a mean of 214.8 and a median of 214.5. The new data set, we are replacing the value because you can only have one all-time high score. So Adam's was 250, now it is 290. So that 290 is replacing this 250. That's the new one for Adam. And we're adding in the rest of the friends, the 180, the 205, and the 224 that stayed the same. So let's calculate the new mean. We've got 180 plus 205 plus 224 plus 290 divided by 4 people is 224.75. And then the median, we are crossing off lowest, highest. We are finding the middle of those two values, so 205 plus 224 divided by 2 gives us that same median of 214.5. So our mean increased because this outlier went up even more. So it's bringing up the average to higher than the rest of them. Versus the median stayed the same because we just replaced the value. We didn't add any other values, so there's still the same amount of data sets, and the outside number changed. These inside numbers stayed the same. The next part of data analysis is looking at different types of plots and graphs and seeing how what their shapes look like. Okay. So we have shape of data. So measures of center, measures of variation. Measures of center tell us the center of the data. Variation tells us how spread out it is. And then the shape can give us information here too. It tells us how the data is distributed. So here we have symmetric, which means if generally I draw a line down the middle, it looks the same on the left side and the right side. Right here, drawn down the middle, the left side looks the same as the right side. Okay, so they mirror each other. And the mean and median, which is important, are very close or the same amount because it is symmetrical. When something is skewed right, okay, when a graph is skewed right, there is a long tail on the right because there is less data there. So we see this little kind of tail. If we think about this as an animal, it's got a little tail going to the right. Okay, so for dot plots and bar graphs, because those look pretty similar, they're going to look like this. Okay, it has less data on the right. So we don't have as much data right here. It's skewed to the right. The right is not that accurate. For box plots, okay, the graph is more spread out on the right because that's the same idea, is that there's less data there. So you'll see this is more spread out on the right side. Versus skewed left is the opposite. There is a long tail on the, this should say right or left. Because there is less data there. So for dot plots and bar graphs, the graph has less data on the left side. So there's less data values here. For box plots, it is more spread out on the left. So this left side is more spread out, okay? Key things to take away. When it's skewed right, okay, that means there's less data values that are higher. The mean is greater than the median, okay? Because we've got kind of like these skewed values that are higher, that are bringing up the mean. Versus here, when there's less data on the lower values, the mean is less than the median because there are these low outliers that are skewing the data. But all we're going to be looking at is determining, is it symmetrical, is it skewed right, or is it skewed left? So when I look at this, and if I divide this, kind of in the middle somewhere, I have more data to the left in my plot, right? I have less data to the right, so it is skewed and inaccurate on the right. Over here, if I were to divide this in half, I have less data on the left side. When we have less data on the left side, that is skewed left. It's kind of pushed to the left, even though those aren't accurate values. Again, dividing this somewhere kind of in half, there is less data on the left, so it is skewed left. So those were 3 kind of dot plots or line plot examples. Let's look at box plots. Remember, it's kind of visually a little bit different. When I look at this one and I break it down in the middle, it looks basically the same on the left and the right, so that would be symmetrical. Here, when I divide it in half, okay, for box plots, if it is skewed to the right, it is more spread out on the right side. It stretches out more on the right side, and it's the opposite for the left. So it is more stretched out on the left side here. This is way longer than that, right? So this would be skewed skewed left, because it's more spread out on the left side. When I look at this one, it's spread out more on the left side again, so it is skewed left. And last ones, looking at these bar graphs. Here, if I split it down the middle, for bar graphs and line plots and dot plots, we are looking for less data to see where it's skewed. There's less data on the left, so this is skewed left. When I look at this one, it looks pretty identical, so that is going to be symmetrical. And when I look here, there is less data on the right, so it is skewed